Okay, this is a look at problem 4 from the homework from WebAssign, assignment 17. This is problem 4. So what we have is a proton. It's moving at a speed. In the case, my speed was 7.70 times 10 to the 7 meters per second. That's the velocity of my proton positive charge. And I tell you that it's moving perpendicular to a magnetic field. The field causes the proton to travel in circular path of a radius of, in my case, 0.800 meters. The question is, what is the field strength? Okay, first we're going to draw a picture. The purple circles with the dot in the middle represents my magnetic field, and they are coming out of the page. The charged particle, the proton in this case, which I know has a plus charge, moving to the right, and they tell me that it's a circular path, and I know it's a circular path because the force is going to be directed downward, down the page, which is going to cause this to curve downward. So I labeled the velocity of the particle, and I labeled the radius of my circle. So the question is, what is the magnitude of the field? Remember, magnetic field is labeled with a capital B. The capital B represents my magnetic field. Now the concept that I'm going to use is the force on the magnetic force on a moving charge. Okay. The relationship I'm going to use is going to be R is equal to mv over qb. This relationship can be found in your textbook, but it is derived from the force on a moving charged particle, where we know the force is equal to Q times V times B. What you don't know is the amount of the force. The force is equal to mass times acceleration. But in this case, the acceleration is going to be a centrifugal acceleration. So the acceleration is actually equal to V squared over R. Once I plug that back in for force, mv squared over R, and solve for R, I get this relationship shown here, which is R is equal to mv divided by qv. So what's known is the radius, the velocity of the particle. I know the charge on the particle because they tell me it's a proton, and I also know the mass of the proton. It's something that you can look up in your textbook or online. What is unknown is what I'm looking for, which is the magnetic field B. So the plan, I start with the equation R is equal to mv over divided by qb, and I want to solve this relationship for B. So I get B is equal to mass times velocity divided by charge times the radius. Now I know the mass of the proton, I know the velocity of the proton, I know the charge of the proton, and I know the radius of its curvature. So I can plug those values in and solve for the magnetic field. So I can now execute my plan by just plugging my numbers in, multiplying and dividing, and I get an answer of 1 Tesla. So the magnetic field that allows this proton to curve with a radius of 0.800 meters is going to be 1 Tesla.